you can get away without missing out. Whether you're traveling across Idaho or just spending more time outside, the Connector keeps you up to date with the local stories that matter, from wildfire season to community news. Stay connected to Idaho with the Connector, Idaho Daily News. Listen wherever you get your podcasts.
From the studios of Boise State Public Radio News, I'm Gemma Gaudette. This is Idaho Matters. Devastating images have been coming out of Nepal as a huge flash flood on Wednesday sent a wall of mud and debris through a river system, ripping up buildings, houses, and bridge. Hundreds of people are missing, and that death toll continues to rise. Now, some of those images are a bit reminiscent of July, when a much smaller flash flood tore through the Grand Jean campground, throwing tons of mud and debris through the area and taking out several cars. Now, there have been dozens of these floods, known as debris flows, in the area of the 2024 Wapiti fire, which burned thousands of acres southwest of Stanley. It's the same kind of wall of mud and water that flooded basements and roads in Boise as far back as 1959, when rain hit the foothills after a wildfire, the same area where the Claremont fire burned this year. Now, flooding caused by burn scars is a frequent problem after a wildfire, and it's something scientists study to prevent loss of life and property in the future. Dr. Jennifer Pierce is one of those scientists. She's a professor in the Geosciences Department at Boise State University and the director of the Earth, Wind, and Fire Laboratory, and she studies how fires change the landscape. Both she and Robbie Jost have studied the area around Grand Jean. Robbie is a second-year master's student in the Geosciences program, and they are both joining us live now to talk more about this. I want to welcome both of you to the show. Thanks so much for taking time for us today.
It's great to be here. Thanks, Gemma.
Hey, thanks for having us.
So, Jen, before we get started, can you tell us the difference between a landslide or a mudslide or a flash flood and what you call a debris flow?
That's a great question, Gemma. So oftentimes these events are referred to as landslides, but they're actually not. So what a landslide actually is when a large mass of rock or soil slides as an intact block from oftentimes a steep hillside. This has a plane of failure and again moves as a mass initially. Debris flows, on the other hand, which are often referred to as mud flows, are turbulent flows, and you can think of them as like a slurry of wet cement, where you have a mixture of water, soil, logs, any other debris that are moving really in a turbulent mass. And those debris flows can be very damaging and destructive, and that debris flow is what we just recently saw images of in that tragedy in Nepal.
So, Robbie, let me bring you into the conversation. Can you take us back to what happened on July 22nd at the Grand Jean campground? And do we know why exactly this happened?
So the first event that ultimately led to this debris flow was the burning of the Trail Creek watershed, which is the watershed where this debris flow came from. It's burning in the Wapiti fire during the summer of 2024. And so flash forward 2 years later on July 22nd, a small parcel of air was rapidly uplifted into the Sawtooth Mountains, centered over that same watershed. And this sudden change in elevation of that air caused a vast amount of water vapor to condense and fall as rain. And the rain reached the ground so quickly that the soil could not absorb that water. And so it began to run off in sheets down the steep rocky hill slopes, picking up soil and rocks and trees along the way. And all of those streams of water eventually came together into the main channel and roared down like a freight train, eventually intersecting the Grand Jean campground.
So, Robbie, if I'm understanding correctly, was that flooding then a result of the 2024 fire that burned so much of that area?
The So the I guess the flooding was directly caused by the rain itself,
Hmm.
but it was exacerbated by a layer of hydrophobic or water repellent soil that was deposited over the surface and by the fire and had remained there over those last couple years.
So, Jen, my understanding is that you did some work in this same area, the South Fork of the Payette, all the way back in 2000. At that time, what were you looking at?
Yeah, so this area, the South Fork Payette, is close to my heart. This is where I did my PhD dissertation work back in the day, like you said, back in 2000. And what I was focused on there were a couple things. First, I was actually digging up pieces of charcoal preserved in sediments and doing what's called radiocarbon dating of that charcoal to reconstruct past records of fires and post-fire debris flows that extend back actually over almost 10,000 years. So those records helped understand, have these events happened in the past? Have they changed in size and severity? So that was one piece of the work I was doing. Another component of the work was doing really the same thing that Robbie is doing now, which was measuring and understanding the magnitude of erosional response or the magnitude of these debris flows after fire and how fire actually changes how our landscapes respond. So they're both, both in the past, my past work in the Payette and Robbie's current work on the Grand Jean campground aims to try to understand how what we call cascading hazards, meaning effects of not just fire and not just a flood, but the combined effects of both fires and rainstorm events impact our landscapes.
So, Jen, you mentioned looking at wildfires over the past 10,000 years. Can you talk to us a little bit more about that? I mean, did you come to any conclusions about that?
Yeah, I did. And I always joke with my colleagues and students that I spent all this time and energy to tell you conclusively, you ready? That fires are bigger and more severe when it is warm and dry. And so that is what we are experiencing now because of our extremely warm, dry summers. When we look back in the past record, we find the same thing. So, for example, during what's called the medieval warm period, about 1,000 years ago, that was also a time when we have records of large, severe fires in Idaho's forests.
Mm. So, Jen, we know that flooding can happen after a fire, but can we dig into how that actually works? I mean, is it just because all the plants burn up, or is there more going on here?
Yeah, that's a great question. It's pretty fascinating, actually. So, when these especially severe fires burn hill slopes, the heat from these fires, so this can exceed 1,000 degrees Fahrenheit or over 500 degrees Celsius, not only completely burns up and destroys the trees and the shrubs, but it actually also damages the soil, creating, as Robbie referred to again, this water repellent or hydrophobic soil. So the heat from that fire drives waxy substances into the soil and it helps create that barrier. Also, the surface sealing effects of the ash from the fire also prevent water from soaking in. So those factors combined, so the creation of those water repellent soils means that when you do have a rainstorm, that rain cannot soak in and instead runs off the surface. And as it does so, it collects along the way the ash from the fire, trees, soil, all this material as it moves down slope coalesces, forming what are called rills, which are like kind of scratches on the hill slope surface. When those rills combine, they form larger and larger debris flows, which again is this slurry of water and debris that can be move very quickly and be very damaging.
So, Jen, Can you talk to us then about how or if a fire can create water repellent soil?
Yeah, so if so these fires and this ties into the Claremont fire, the creation of these water repellent soils really does depend on the heat of the fire. So how hot is this fire burning? And that will depend on what type of vegetation is burning. It also depends on how long the fire kind of spends on those soils. So if a fire like the Claremont fire is a fast-moving grass fire, the damage to the soils may actually be quite a bit less than in a pine forest where you have trees that are burning large amounts of material and that fire is kind of staying on the landscape. So that's how so the fires, again, the generation of these water repellent soils is through that surface heating and driving down into the soil profile, usually about, 2 to 4 inches down. This actual layer that we can see when if you drop a drop of water on it, that water does not soak in. You can wait for
Mm.
hours and there'll still be a water drop there. So that's what we do out in the field to test for the evidence of this water repellency.
And Robbie, why is it important to study these burn scars? I mean, who uses that information you're gathering?
Yeah, so like all geologic hazards, the impact of post-fire debris flows on human life and infrastructure can range from fatal and devastating to merely inconvenient. So by studying these processes, we're looking for insights on which outcome that might be, whether it's fatal, inconvenience, or something in between. And our goal is to communicate those hazards to local land managers and cities and to the public at large. So I'd say everyone is impacted at some point by geologic hazards.
And what do they do with all of the data, Robbie?
So our goal really is prediction. This group with the U.S. Geological Survey is a specialized branch of that program called the Landslide Hazards Group. And so have been working to develop models that take a bunch of information about the recently burned landscape, plus information about typical rainfall patterns to estimate the likelihood and the size of a debris flow that might happen when a certain amount of rain falls over a burned area.
So, Robbie, I'm curious. After one of these rainstorms happens, how quickly do you want to get out into the field?
It depends on when, if anything, happens. We kind of rely on reports from people that are in the area to see if there was an event that's worth investigating. But if it is big enough, sometimes you just want to go roll the dice and see if you can witness something in real time. But really, as soon as possible is important. It's
Mhm.
pretty well known in the literature that these events happen pretty quickly. Debris flows are initiated pretty quickly after it starts raining. So it can, but the effects last for a while. So once a debris flow is in place, you kind of have some time to go look at it.
And actually,
Well,
yeah,
and,
we're
and
Robbie's heading out tomorrow to do some more field work on these most recent flows. So he's been very busy.
it sounds like so. I'm curious then too. So, Robbie, I mean, you were literally out there. You're digging into these deposits, and then you're actually bringing bags of sediment back to the university. So, what can a bag of dirt and rocks tell you about where the next debris flow might go?
Uh, Collecting the sediment doesn't really answer that question per se.
Hmm.
We use it to understand more what kind size of rocks are in that deposit, and so where they might go after, or as where they might go after some time or when they start to move again. And so that has big impacts for the downstream effects of fire and how that might influence the ecology of the river or even infrastructure infrastructure like Highway 21 downstream of Grand Jean.
And clay. Another big thing is that clay content that can really transform what would just be kind of a sediment charged flood. If there's more clay, that really is more likely to create a damaging debris flow.
And Jen, how good are we at this point at predicting maybe a post-fire debris flow? Is that even a possibility?
Yeah, well, I would say again, so Robbie referred to the U.S. Geological Survey and their hazards group. So the USGS, I would say, is really leading the way in developing these predictive models for debris flows. And they've done this following, for example, the Palisades fire near Los Angeles. They have created post-fire debris flow predictive models for the Claremont fire and for the Wapiti fire. So now what we're doing and what Robbie's thesis work will really contribute to is a better understanding of how those models work in different areas and how, for example, different weighting in the model of the precipitation duration and intensity, slope angle, the soil characteristics, and the burn severity all factor in. So the USGS is actively, working to update these models and understand how we can best provide that needed information to the public so people can prepare for these destructive events.
Yeah, and
So with
I'll note that this storm was actually very well forecasted, and that's the big
Mhm.
component of prediction for these debris flows. You can assess the conditions right after the fire, but then you're just end up waiting for the next rain event. And so leading up to that 22nd debris flow, the Weather Service had good reporting on this, that there was expected high intensity rain, and so put out a lot of messaging that
Mhm.
some debris flow impacts could be expected in the Wapiti burn area.
So with that said, and Jen or Robbie, could the research that you're doing at Grand Jean in particular eventually maybe change when Highway 21 is closed during storms? I mean, is there a possibility that with the research you're doing, the Weather Service would say, you know what, we need to maybe close certain stretches of road, even maybe before we have impact?
Yeah, potentially doing this work and combining it with the larger nationwide inventory of post-fire debris flows could make our predictions more accurate and understand kind of where on the landscape these debris flows might happen. And then that's really kind of a relationship between the weather and the debris flow mechanics.
And Jen, I think a lot of times when we, hear about flooding at places like the Grand Jean Campground, which is not far from Stanley, I think there might be an idea that, well, we're safe if we're in the middle of a city like Boise. However, there was a massive flood back in 1959. Can you take us back and tell us what happened?
So this is another example of, again, one of these cascading, what we refer to as cascading hazards. Um, and there's a wonderful video, if people haven't seen it, called When the Pot Boiled Over about this event. And it has dramatic 1959 music, etc. So this interval, so August 3rd, 1959, the Boise foothills were burned in a fast-moving range fire. And after this, on August 20th, 1959, over an inch of rain fell on the Boise foothills. So those two factors combined created this chain reaction where, again, we had this burned landscape, we had a very large precipitation event, and the east end of Boise was flooded with debris flows, mud. Fortunately, no one lost their lives, but this was really a wake-up call to the city about the dangers of post-fire debris flows and flooding. In response to that, then the management response was to cut these trenches on the hillsides that are still visible today. And the goal of cutting those trenches was to try to catch that sediment before it caused a debris flow and a flood.
Mm. And Jen, back in 1959, when that flooding happened, I mean, when how extensive exactly was it? What were people dealing with?
Yeah, I mean, it was fortunately, there are not a lot of large boulders in that watershed. So most of the
Hmm.
flooding was more kind of mud, essentially. But it was, if we think about Robbie's ideas of, deadly versus a nuisance, a lot of folks were digging their basements out. Fortunately, people who were sleeping in basements in the East End were able to escape. But this affected many of the neighborhoods throughout the East End of Boise and in that area of Cottonwood Creek, where we currently have, the bike park and the dog park, and those ponds. Again, the purpose for the bike park and the dog park is not for bikes and dogs, but for flood retention. So it
Hmm.
really would be many of those communities downstream from Cottonwood Creek outside of Boise.
So this flood that happened in 1959, and as you said, Jen, it was because of this fire that burned in the Boise
Mhm.
foothills. Is this the same area then that just recently burned in the Claremont fire?
Yes, it is. So not exactly, so the footprint isn't exactly the same, but this recent Claremont fire did reburn many parts of the Cottonwood Creek and Freestone Creek watersheds that were burned in 1959. So that's one thing that we're very interested in, as I'd say both Robbie and I are what I like to call pyrogeomorphologists. So scientists who study how fire affects our landscape. And we're working with other colleagues here at Boise State and the city and the BLM, et cetera, to both understand the impacts of this fire on our sagebrush steppe communities. Dr. Anna Bergstrom is working to understand the impact, working with the USGS to understand the impacts of this fire on water quality.
Mm.
And myself and other graduate students in the Earth, Wind, and Fire Lab are interested in how this soil burn severity may contribute to post-fire erosion.
So I want to shift gears a little bit, if we could, because I know so many people on top of mind, especially since seeing the video, are those floods that happened in Nepal yesterday. And I know, Jen, that it's not the same as a wildfire and then a flash flood. However, with that said, devastating flash flood in Nepal yesterday.
Mhm.
What do we know
Yeah.
so far about what caused that flooding?
Oh, yeah, what a tragedy. There actually are quite a few similarities between these post-fire debris flows and the tragic debris flows in Nepal. So both of these are examples of climate-driven cascading hazards. So the
Mm.
trigger for the Nepal floods was massive collapse of a glacier. Um, and the reason that glacier is collapsing is because of human-caused climate change. Similarly, for the fires outside of Grand Jean, the reason why Idaho is experiencing such large and devastating fires now is because it is so warm and dry. So, so thinking about the triggers, again, for the Nepalese landslide, they're calling it a landslide. That was a collapsing glacier, which then produced a very large and very deadly debris flow. So from what we understand, and this is all evolving right now in the
Hmm.
scientific community, but the latest news is that that collapsing glacier, which was, equivalent to over 25 soccer fields, so 2 million square feet of glacial collapse, triggered then that the actual collapse of that ice and the debris flow created a small earthquake. So it was initially unclear whether an earthquake triggered this event. What it now appears to be is that the event itself of that collapsing glacier triggered the earthquake, which then produced this deadly debris flow.
So, Jen, due to our warming climate, could we see something like what happened in Nepal happen in Idaho? I mean, is there a danger of a disaster on that scale? And maybe not even here in Idaho, but potentially in the U.S. I mean, I'm thinking just of the West, of places like Alaska, maybe even the Rocky Mountain National Park.
Exactly. And so those are the types of questions we need to be asking ourselves and preparing for in a warming world. So, of course, Nepal has, I believe, over 60,000 glaciers. So, whereas Idaho, we don't have really any active glaciers. So the exact mechanism would not be similar for here in Idaho. However, I think you're right to ask questions about places in Alaska and the potential hazards from glacial collapse and glacially collapse triggered floods in Alaska. That is something to be concerned about. Here in Idaho, really the biggest danger I would say that we have from climate-driven hazards are wildfires. And fires, both the direct effect of the actual fire and again, these cascading effects from post-fire debris flows, wildfire smoke, which of course is very bad for human health, and the very large economic impacts of fires and kind of psychological effects of fires. So these fires really do affect Idaho's communities on multiple levels. That said, I think the having a kind of glacially triggered event like just happened in Nepal and Idaho is unlikely. But flooding and rain on snow-driven floods will likely become much more frequent in a warming world.
Well, I want to thank you both so much for coming on and talking to us about this. We've been speaking with Dr. Jennifer Pierce. She is a professor in Boise State's Geosciences Department, and master's student Robbie Jost about the dangers of flooding after wildfire. And that'll do it for this episode of Idaho Matters. Make sure you check out our podcast feed because you can find more episodes of topics that might be interesting to you. And for more local news and headlines, make sure you subscribe to the Connector podcast. Just by listening, you're helping to support public radio right here in Idaho. And I want to say a big thank you for that.